Hello, hello, hello. This is another, when you say another video for physics enthusiasts, because there was a delay for the connection of our Wi-Fi here. I mean internet connection. So today at 11:25 a.m. in the Philippines, I would like to explain to you or some, discussion about termin- terminal velocity. When you say velocity, that is the distance covered per unit of time. But when you say terminal velocity, this is also called settling velocity. Because once the object reaches the ground, for example, if you throw the object vertically upward, the influence of the gravity will now easily goes down. The object goes down or it fell on the ground because of the greatest impact or influence of the gravity small g. And when the force is upward, okay, that is the direction, the air resistance is large enough to balance the downward force of gravity. That's why the air force is sometimes negligible because greater impact, as I said, of the gravity. Air resistance is the result of an object flowing through a layer of air and colliding with air molecules. The more air molecules collide with an object, the greater is the air resistance force if the object is very heavy. But if it's just a little heavy, then the air resistance is become negligible. Now, consider an apple and a feather drop from a, let's say, high building. As it falls, of course, both the apple and the feather are being pulled by the force of gravity, but normally the apple initially dropped. When you say initially dropped, the apple reached the ground first. Okay? The force of gravity becomes unbalanced. Unbalanced because of the fact that there is no air resistance that can balance its weight. Because apple is heavier than the feather, therefore the apple easily fell on the ground because of the influence of the gravity. And it became unbalanced because you momentarily drop the two objects, I mean, at the same time, but because of the gravity, the apple that has a greater weight moves down faster. But the feather also moves down, but there is unbalance on it because of the weight of the feather. The apple, as it falls, approaches its terminal velocity but does not reach it. On the other hand, as the feather falls, because of its light weight, air resistance can easily balance its force of gravity. The reason why it sways with air. Remember? That's why you sway on air. Even if you are using, for example, the one that is parachute, okay? You sway because you have to balance your weight with the air. When the force of gravity of the feather is balanced by the force of the air resistance, the net force becomes zero. Because if you go down, it's the direction of the weight is normally down, negative. But if the object is still on the air, I mean up there, it's positive. So if you add that, it becomes zero. And the feather reaches the terminal velocity when it became zero. The feather will continue to fall down with zero acceleration because of reaching the terminal velocity. If an object accelerates downwards due to gravity, The drag force acting on the object increases, causing its acceleration to decrease. At a particular speed, the drag force produced will equal object's weight. That's why, according to Newton, W equals mg. That m stands for the mass of the object times the acceleration due to gravity, which is also equal to the force downward weight. Normally, that is the downward force, normal force, but it's equal to weight. Because you cannot go down without considering the weight of the object. More drag weight means a lower terminal velocity, while increase the weight means a higher terminal velocity. In other words, the heavier the object, the faster the gravity that pulls down, and your terminal velocity is negative. But if you're a lighter object, your terminal energy becomes zero when you reach the ground. Okay. The resistance and delay the fall of an object, a resistance particularly, yes, because there is also a force upward and there is a force downward. The downward is the normal weight, very normal force, that is the weight. But momentarily you are swinging there, but there is still a force that is unbalanced. Once you reach the ground, it becomes zero because it is already balanced. Okay. For example, the parachute, for example, as it opens, then it slowly goes down, decreases the velocity. And then the velocity becomes constant when the body is reached 2.5 meter per second to 7 meter per second. That is the constant value for velocity when the parachute is blown down. And another instance is when the ball reach, let's say, baseball, and it's stay momentarily in the airspeed and become zero when it reaches another side or anywhere else because the ball hits the ground already, and that's the time the velocity becomes zero. When the drag is equal to weight, the ball no longer accelerates but holds a constant velocity, which is called terminal velocity. An object needs an initial velocity for it to go up. A ball thrown upward finally comes down. The velocity at which it is thrown is the same as its final velocity when it reaches the same point of elevation. The time of ascent is equal to the time of descent. Gravity decreases the velocity of an object thrown upward, so its motion is negatively accelerated. Just like from the top, it goes down negative because it is approaching the south direction, downward. It becomes to a point when its final velocity becomes zero. At this point, it has reached the maximum height. Yes. If the ball reaches the upper portion and it goes down, the velocity becomes zero because it is already equal to the force of the weight downward. So that is terminal velocity. Okay. And that is how the settling velocity measured. We have some formulas here, but we will try to solve later on because it's already 11:34 in the morning and we assume that we have supposed to take ours in 2018. And please subscribe, like, and share my bestseller international author YouTube channel. Thank you.